you still have energy for this talk, right?
Thank you. Okay, so I was, as I said, my name is Cristi Gherghe, and I'm a principal consultant at Upwork. And today we will discuss about engineering development. So, I think most of us today are engineers, right? And maybe some managers too. So let's see how some people define engineering. Some might define it as activities and function of an engineer. Others like to call it design and manufacture of complex software systems. But I think that the definition is activities and practices by which software is built and made useful to people. And it looks like it's not only about activities that you do in your day-to-day job as a developer, engineer, it's also about the practices that you use. And let's see what these practices might be. And of course, we have the usual suspects from the DevOps world. We have continuous integration. We have continuous delivery. We have as well infrastructure as code and shift left on testing. From Agile, we have communication and collaboration, which I think is key to any high-performing team. While from extreme programming, you might want to leverage TDD, test-driven development, and time-based development, and other practices. So we at Topworks have a set of practices that we call sensible defaults. They are not stepping stone, they are just a set of recommendations. And they are meant to help our growth. So you might say, oh no, okay, but what's in for me? I mean, some of us might see adhering to new practices as a burden, right? So it's always something to learn, something we learn, and maybe new pressure. And for this, we will look at the benefits of having such practices in place. So, just in a nutshell, I think leveraging a good set of practices, you can build high-performing teams that will actually cultivate and foster a culture of innovation and experimentation that will actually be set to deliver continuous value to your customers with futures that are tailored to their needs, giving them real value. And I think all this we can summarize it a little bit different. And you can see it as engineers with practices will give you high-performing teams. And you as an engineer definitely want to be part of such high-performing team. You will be in a better position to grow and to have satisfaction as an engineer, continuously delivering value to your customers. But we have also this one. Managers with high-performing teams will actually give customer value. And customer will always get continuous features as tailored to their needs. which give them real value. This one I think we can simplify it a little bit, and we can take this one. Managers that will cultivate practices in their teams will actually be set for success stories. And everyone loves success stories, right? So, thank you. Now, I think we can go on, and I invite my colleague Roxana Mecea to speak about bugs. Thank you.
Hi everyone, my name is Roxana Mecea. I'm a senior Android developer at Terraform Romania. I am also a trainer at Google's workshop teaching Android fundamentals. So today we are talking about shifting left and right. It's a very easy concept. Let's see what shifting means. A bug can be found during development, in QA phase, but worst case found by our users in production. And users finding bugs is usually costly and not so easy to fix. On the other hand, when we find a bug when we write the code, it's not even a bug anymore. Therefore, there is this concept of shifting left on bugs where we aim to find them as soon as possible. Easy said, but in practice, it's not always straightforward. Along the way, I did a few mistakes, and today I want to share them with you. Let's go through the grind. Let's imagine that on July 31, a release is scheduled, and getting it right is quite important. So we are asked to give some estimates. We do report the estimate with and without testing. Have you ever had a discussion along the lines, well, we cannot invest right now in writing automated tests because we need to ship this as soon as possible. Therefore, our management decided to go with a smaller number. What usually happens, we finish a user story, we assign it to QA, we find some bugs, we fix some bugs, and the process goes on and on. Having testing at the very end doesn't seem to help us with the estimate. It's a pitfall that testing sooner, writing automated tests will take more time. So we had our release anyway. Now our company does see the value writing automated tests, so they hire the team doing exactly that. Now we are assigning the user story system to test out. According to the meta study from Accelerate Group, having a separate team doesn't bring any value regarding finding bugs sooner. So separating testing from the developer world is an anti-pattern. Now our developers are writing their own automated tests. Management decided to have a minimum target of 75%, so our developers are writing tests all day long. Unfortunately, we see that they are more focused in increasing the coverage target with low quality testing. So testing afterwards is not really shifting left. Furthermore, when we write tests afterwards, we are more prone to test the implementation details, asserting that our code does what it does. A better approach is to test our code for behavior, for what it does, not how it does it. So when code changes in time, the test should fail and not become invalid. For instance, in this unit test, we are verifying how our view model interacts with another class. And this is really coupled to how we achieve the end result. A more interesting approach is to add some behavior to this kind of unit tests. So we need to make sure that we are testing for the right reasons on the right way, because just by testing doesn't mean that we will fix everything. We need to make the testing count. Often when we write tests, big tests, end-to-end tests, we might fall for the idea of achieving full regression. But when an end-to-end test fails, now the failure range is expanded to the entire system. Basically, along the way, anything could have broken. A better approach is to widen this perspective and understand the full testing pyramid. Because each kind of test has its own trade-offs. And it's not just about the pyramid. There are many ways of testing in software development. For instance, there is this concept of fitness functions that was first introduced in building evolutionary architectures, written by Neil Ford, Rebecca Parsons, and Patrick Watts. This is a really good book that we in ThoughtWorks are very proud of. Basically, fitness functions are tests for a specific architectural requirement. And we can write this kind of fitness functions in different ways. For instance, there can be triggered by an event as a rule. There can be continuously when we monitor if our server is still up. There can be atomic as a unit test as verifying cytometric complexity. Or there can be holistic. For example, when we check the security or scalability of the app. So we need to make sure that our testing pipeline is well understood and evolving. Another interesting point that I got wrong a few times regarding shifting left is continuous integration. We all know what continuous integration is, but getting it right is quite important. Instead of working for days or even weeks on the same branch, we need to push good testing code at least daily into master, even if the feature or user story is not ready, or even if the feature is not visible for the QA or for the user. That takes a mind shift. A better approach is to work on small iterations, because small iterations are the foundation of having a good software delivery performance, having less bugs, iterate faster, gathering information, and integrate sooner with the team. So lead time is the time from when a user story is put in progress until we decide to integrate it for a plausible release. Is one of the 4 key metrics that defines good software delivery performance. And it just reached the adopt level in our latest technology radar at ThoughtWorks. So when user stories take weeks, there are a lot of bugs on the right side, but also on the left side. We are tech people and we think that everything can be fixed with a technical solution or a development process, right? We wrote the definition of done and we think that from now on, everything will go smooth. Just because we have a definition of done written somewhere doesn't mean anything. Code reviews, pair programming are just ways for us to communicate. And it depends how well we are doing all these things. Concentrate on team relationships, engineering culture, not on things that can just check the boxes. Transformational leadership comes in handy. According to the meta study from Accelerate book, instead, nurture a good culture to achieve the end result is better. Therefore, instead concentrating on technical aspects, we need to concentrate more on relationships, organizational culture to achieve the end goal. I think this screenshot is quite familiar for everyone. It's the kind of problem that we have been doing during our college years or for some technical interviews nowadays. It's about the problem, our solutions, and validation. As a parallel, the problem can be a user story from our time. We start writing some code, and we hope for minimum numbers of bugs. But there is a problem with this, because we see that we are so much concentrating on writing a good solution that we don't even see that understanding the problem, validating the solution, is more than half of it. So software is really costly to write, but it's also cheap to replicate, and testing should be also replicable. And I think we need to do a better job teaching this to our next generation. So we need to shift the way we teach to shift left from bugs. So now I will shift to right to my colleague Amit to present his talk. Thank you.
Thank you, Roxana. Okay, so as the next topic of this talk, we're actually going to shift left now. And we're going to talk about some of the automated tools. So we're going to talk a bit about automation. And as part of that, we're discussing some set of tools to bit of automation around Terraform testing. Before I do that, here is a quick question. Can you think of the time a team of engineers spent to test their code manually? A million minutes per year. And that's an estimate for a team of decent size in any organization which has no automated testing setup in place. My name is Amit, and I have been working as a lead infrastructure consultant for Portugal, Romania. I've got around 14 years of IT experience. My IT experience is spent in multiple countries. So for a few years I worked in India, then I worked in Germany, and for the last 6 years I'm working here in Romania. On the technical side, I'm a certified Terraform SCA and have been writing testable infrastructure for more than 3 years. We at Thoughtworks have managed to find the right set of tools to automate the testing of our infrastructure code. And today, as part of this talk, I try to walk you through these tools and we try to see how they fit together. So let's get started. Before I talk about the tool sets around Terraform, let's quickly try to see what actually Terraform is. So Terraform is a leading infrastructure as code tool, which in simple language means that with Terraform we can write infrastructure as code. We can write infrastructure in configuration files, ship them to Terraform, and Terraform knows what to do with these configuration files. As soon as I said that Terraform is an infrastructure code tool, obviously it contains all the features that any infrastructure as code tool does. However, there is something really interesting about Terraform. It's cloud agnostic, in the sense that with Terraform, we can provision infrastructure for Google Cloud, for AWS, with Azure, or any other cloud provider. And the really interesting part is that the kind of workflow to provision infrastructure with any of the cloud providers remains quite identical, in the sense that you just need to understand 3 simple commands. init, plan, and apply, and you're all set. You can have these running on GCP, you can have them running on AWS, or you can have them running on Azure. And that really makes Terraform powerful. Okay, I think enough for Terraform. Let's quickly jump to our actual topic. Automation testing. But I mean, as human beings, we always ask ourselves why we want to do something. So in this concept, the obvious question is, why do we want to do automation testing? We started with this number, and we understood that we are losing this time. Why not save this? If we can move from manual testing to automation testing, we're going to save 1 million minutes per year for us and for our team members. So that's one of the reasons why we should move from manual to automation testing. But there's another reason, which probably most of you must already be familiar with. As the organizations are nowadays moving to more agile way of working, the most of the focus remains on continuous integration and continuous delivery. As part of continuous integration, we want to build things quickly, and as part of continuous delivery, we want to deploy them to a specific environment. But there's something in between which is actually bridging these two. So we have continuous integration, we build things. We have continuous delivery, we deploy things. But can we do it without automatically testing them? I don't think so. And that's one of the really important reasons why automated testing is needed. So that we build things, we test them automatically, and then we deploy them automatically to the target environment. And that's really going to automate the full end-to-end process. And that's one of the second reason I would say, why do we need automated testing? So, hopefully, at this moment, I have managed to convince you enough that automated infrastructure testing is required. But the next question comes, how do we do it? For Terraform, automated infrastructure testing is done in 3 stages. And the reason we are doing it in 3 stages because we want to sit on lab. We want to find out things quickly rather than being identified at the later stage. These stages has to be done in the same sequence as they are listed here. So we do something called static analysis. And as the name suggests, static analysis means we are analyzing the code without actually doing anything with it. So we write it and we just test it. And this is pretty easy for developers because that's something they can do on their own machine. They really don't have to do a CI/CD pipeline, or they don't have to find some specific tools for that. So as a developer, you just write code and then you supply that code to some specific tools and they do static analysis for us. And we're going to talk about those tools in the later slides. The second stage of automation testing in Terraform is called incremental analysis. Why incremental analysis? Why not doing the full analysis? The reason being that for the tools like Terraform, you always provision data. So we created some infrastructure. Next time we want to change something, we don't destroy things. We just quickly provision the data part, the change part. And when we are changing something, we want to analyze whether the change part is still aligned or is still compliant with our organization policy. So as part of incremental analysis, we basically analyze our data code against certain set of organization policies. And that's why this is also called as policy-based analysis. Another piece here is called functional testing, and this is really important. We are functionally testing the infrastructure in the sense that we actually going to write some test cases. We're going to provision the infrastructure on a sandbox environment or a temporary environment. We're going to run some test cases against that environment. And if everything is okay, we say, oh, now it's all right. Let's move further. If something breaks, we're going to pause right there. We're going to look into the code, fix it, do the analysis again, come back and apply it again. And then the cycle goes on until we get it right. So It's more like any software development where you do functional testing. We also do the same for infrastructure code. So let's talk about the kind of tools that we can use for each of these stages. So I'll start with static analysis. As we said, static analysis is like analyzing the code without executing it. We're starting with the lab. The first tool that we have in the list that can do static analysis for us is called TSSAT. What it does basically? Some of you might be familiar writing in some structure. You're trying to create a storage bucket. I'm just using some technical terms here. You never want it intentionally to be accessible to the outside world, but probably unintentionally you wrote some code, and now the storage bucket is visible to the entire world. If we use static analysis code tools like TSSAT, these are the kind of things that can be avoided. TSP is going to complain if you're going to write this code. So the tools like TSSAT, there's security best practices for our Terraform code. They have certain rules, and when we apply the Terraform code against these kind of tools, they're going to complain about some of the best practices that you have to follow in order to write better infrastructure code. The second tool that we have in the list is called TF-Link. If you're doing front-end development, then probably you must be familiar with the concept of linkers. They are basically used in front-end development for code quality analysis mostly. And this is exactly what it does here. For Terraform also, we developers try to write code, and then over the time we also try to change things. And what happens in this whole process that we try to declare variables, but we forget to delete them. And if you does that, and if you're going to pass your code with TFN, it's going to complain about that. So it's more like cleaning the code so that you have better quality of code at the end. And the last but not the least, the tool which can help us with static code analysis is called Terraform Validate. It's a command which comes with Terraform, and it actually verifies your infrastructure at the very early stage before it actually reaches to the actual target deployment stage. Okay, so we talked about static code analysis. Let's talk about the second stage here, and that's incremental analysis. As part of incremental analysis, we always verify data in the sense we already provision some code. We want to change things, and as part of that, Terraform is going to show us what's the data. So if we start on the left, we run something like this command, and Terraform is going to tell us what it's going to provision in order to reach to the desired state. We're going to convert this output from Terraform to a JSON by using the steps from the middle. And once we have that, we're going to supply it to a tool which is developed by Google called Terraform Validator. And what this tool does, it analyzes our change against certain set of organizations' policy, and that's why this is also called policy-based analysis. So what we are doing here, we are supplying our data.json, that's the JSON file or data code, to the set of policies that we set up for our organization. And then this tool is going to tell us whether any of the policies is violated or not. If nothing is violated, then we are pretty good. Everybody is happy. But if something is violated, then we need to go back, we need to find out the reason and have to fix that. And that's gonna make our code more compliant, more policy compliant. The last stage that we have for automated testing for Terraform is called functional testing. As a developer, we always work in different branches. But in the end, we want to merge everything to main branch so that this can be applied, the final code can be applied to the actual environment. While doing that, we also want to put some checks in there so that nothing goes to the main, which is not already tested. And this is exactly what we're going to do as part of functional testing. So if we start from the sequence, we started a new branch. In that branch, we made the required changes. We made PR to merge to the main branch. Now, before we merge to the main, we want to check our code because we really want to make it have the clean code. And that's where we can introduce another set of tools called Kitchen Terraform and GCP Impact. What this tool does, it actually provisions our infrastructure, everything that's coming from step 4 to a temporary sandbox environment. Then it's going to run the test cases on that environment and see whether everything is okay. If everything is fine, then it's going to break that environment current completely, and then you are going to be merged to the main branch at step 6. And then you can start provisioning of your infrastructure on the actual environment. So basically, the functional testing in Terraform requires two environments. The first one is only the temporary environment. You just use it to provision the infrastructure temporarily. Test your code if everything is working fine. And if everything is working fine, you will destroy the environment completely and then push up your code to the target branch so that it can be merged to the actual environment that you want to see at the end. Alright. How does it look like in a pipeline? So what you see here is a GitHub pipeline. And what we're trying to do here is to introduce it in an automated CI/CD pipeline so that before the infra get provisioned, all the static code analysis and the incremental analysis are there by default. On the lab, we are using this tool called TSF, and this is doing a security analysis for us. For our Terraform code, we are using this TF link to link our code, and then we are using Terraform validator to validate our code for the organization policies. And if everything is okay, then things on the right are being executed in order to actually provision the infrastructure. Really important. We really have to test our code thoroughly before we can, or we should, actually deploy it to the environment if we want to see it. This is the example pipeline for functional testing. And if you see here, we are using a set of tools called Terraform and Impact. And from the top, we are using something called Kitchen Create. And that's where we are actually provisioning the infrastructure to the temporary environment. And as part of Kitchen Verify, we are running all the test cases. It could be anything. As a developer, we have to write the test cases accordingly. And once everything is okay, we have Kitchen Destroy at the end. And this is going to destroy your complete temporary infrastructure. Okay, so that's about automation on Terraform. We have thought about highly encourage automation, and that's why we would like to encourage you all to look for automation in your day-to-day work, whether it's related to general coding or infrastructure coding. If you'd like to read more about the set of tools which I just described, if you'd like to read more about ThoughtBot, or if you want to connect, then please follow this URL. Thanks for listening. And with this, I'll invite my colleagues, Roxana and Cristi, here on the stage for Q&A. Are there any questions on?
I think everybody is waiting for the lunch. But there is.
Hello. This is Bjorn. It's great to hear. Can you detail about how that is actually done?
I mean, I'm just going to repeat the question actually because I really had difficulty hearing it. So you basically trying to understand that how functional testing actually works for infrastructure tools. Thank you. That's a very interesting question. I have been asked this question multiple times because for infrastructure point of view, the functional testing doesn't look very logical. People think that we can validate the infrastructure by just using it. You really don't have to thoroughly test it by writing some test cases. But that's not completely true until you really hit something which starts breaking through. So that with the approach to function testing, we create a completely temporary sandbox environment which we actually gonna only use for functional testing. We write all the code that we need. It could be any tool. What I just told is by using Terraform, but it could be any other tool. And then, by using the logic, we apply this code to this temporary environment fully, as we will apply to the actual environment. And then we run all the test cases, and that's where this tool called inspect helps us against that environment and see whether everything is okay. If everything is fine, then we merge it to the target environment, and that's where it actually gets deployed to the environment where it really wants to be deployed. So this might look a bit costly because you have to manage an additional environment, but it really comes within the benefit. So yeah, I highly recommend doing functional testing for infrastructure code.
Any other questions? Please.
Hi, thanks for the presentation. My question is for Roxana. So you suggested that we should shift left on teaching, but could you give an idea or suggestion how this could happen in practice?
I referenced them in my speech. For example, my suggestion is that you move testing in earlier stages. That's my point because, yeah, as I said, we are so much concentrating on the solution, we start writing the code, but I think a better solution is to start writing maybe some TP tests, and this is how we move shift left. We move testing early in the system.
So we also teach DDD first. Yeah, I was asking about teaching.
Teaching. Maybe when you have a junior at your working place, when you give him some work, maybe you start asking him, okay, let's start writing some tests first, thinking how the solution should be tested, to find the worst cases, best cases, and so on, and then starting writing the code. And then you will find a good solution that it's better, and you will not change it. Maybe something is wrong, you wrote the code wrong, you delete the entire code and starting again.
Thank you. Hello everyone, thank you for your presentation. I think my question is for Amit. What happens with the CI/CD pipeline if one of the test cases fail?
So the normal behavior is that the pipeline is going to fail, and the code won't get deployed to the actual environment until you really fix it. But it all depends on the use cases, how you actually design your pipeline. In our case, from Thoughtworks point of view, we are quite strict on the quality of the code. And that's why we'll ensure that any fail, it actually fills the pipeline so that code doesn't ship to the actual environment without being thoroughly tested.
For example, if one test case failed, the other test cases will continue to run, or the entire pipeline will stop.
The entire pipeline is going to stop.
Thank you.
Thanks for the presentation. One question seems the topic that is also mentioned security. Curious how you're dealing with sensitive information in the Terraform state.
this is a really interesting question. In general, this is really difficult to handle. I really have to admit that. There are a couple of ways we are trying to handle it. The first thing, we consider our state file as a sensitive thing, which means we are keeping it to a place where it's highly protected and only authorized persons are actually able to access it. Because the state file is a text file, it's a JSON file, and anybody can read it, even the templates. So that's one thing. And second thing, what we are doing, we are trying to handle the secrets within the pipeline rather than shipping them to the state file to a certain extent. So anything that we think can be done outside the ambit of Terraform, we try to do that. So we try to write certain things within the pipeline. And that's where the GitHub secrets really help, because you can't see them. Even if you use them, they are completely protected, so nobody can read them. But still, I fully understand there is a risk that things might go to the state file and people can still read them. And that's where it's really important that you use a concept called remote state in Terraform. And we make sure that only authorized persons from teams are actually authorized to access this information. But thanks for the question. Really interesting question. Thank you.